So let me show you one unusual question with respect to P3 integration that came during October number 12 paper 3 variant 3, and I'm talking about the second part of question 7 in the paper. The first part was simply integration using substitution, and not a lot of students were struggling with that. I would say that I have got a lot of common questions from part 1, not how to integrate, because integration using substitution is just the same thing again and again, just like how I taught you in the previous question over here. That is, use the substitution, do the derivative, then do the substitution, change the limits, and then keep on integrating. But the difficult part that students found in part 1 was to find the limit over here. That what will be the limit over here? So over here, we know that I am trying to find the values of x. The first value is obviously 0, as you can see over here. But what is the next value of x where my equation can be 0? Now I have to think either this could be 0 or that could be 0. So which one becomes 0 first after the x equal to 0? That is what I'm trying to find out. So I know that either my sine cube 2x is equal to 0, and then if I take cube root on both the sides, I'll get sine 2x equal to 0. Or in the same way, I can say cos 2x is equal to 0. Now I can plot the graph of the sine x and over here for the cos x, and look at for what values of x my graph gives me 0. So after 0, my sine graph gives me 0 at pi. And over here, the first value where I'm getting 0 is at pi by 2. So I know that the value of 2x must be equal to pi by 2, because after 0, this is the closest value to 0, or after 0 at which this equation can be equal to 0. So my 2x is equal to pi by 2. So from here I can say that x is equal to pi by 4. That is how I know that the highest value of the limit, if you integrate this curve, will be pi by 4. Of course, there are values like pi, 2 pi, then 3 pi by 2. At all these values, the output will become 0. But which is the value that is just after 0? Of course, that was pi by 2. And we were solving for 2x, remember, not x. So 2x will be equal to pi by 2. From there, you got x is equal to pi by 4. So I hope that the confusion that usually people struggle with is clear for the first question. After this, just do the regular process and find the integration using the substitution method. The answer for the area will come out as 1 by 24 for the limits 0 to pi by 4 if you will integrate this equation. Now let's move on to the actual problem, the second part. The question is talking about, given that the integration of this equation, the same equation, but with a modulus sign from 0 to k pi is equal to 40 times the area. We are supposed to find the value of constant k. Now, quite some students think about, we have not learned about how to integrate whenever we are having a modulus sign. But the question is not about how to integrate with the modulus sign, rather utilizing the given information of the diagram and the answer we have got in the previous part, and then eventually solve the second part. What is the meaning of the modulus sign? Let's try to understand that. It means that none of the part of my graph goes below the x-axis. Rather, it will be reflected in the positive y-axis. It will never go in the negative y-axis. So let me reflect this below part on the top. So it's going to look something like this. So now even this is counted as your positive area. Of course, the value of a, as we have found, is 1 by 24. And like this, we have 40 different such areas from 0 to k pi. Now, how can we find out the value of k? That is the main question. I know that in 0 to pi by 4, so basically for every pi by 4, the area is coming out as 1 by 24, or let's call it as a. For every pi by 4, I am getting area a. So for 40 areas, I will have how many pi by 4s? It will become 40 pi by 4. So 40 pi by 4 is nothing but 10 pi. So from here, I can say that if I go from 0 to 10 pi, all of these values of a's will come 40 times according to this calculation. Let me repeat it once again. For every pi by 4 interval, I know that the area is a. And then because of the modulus, it will keep on continuing. This is pi by 4, this is pi by 4, this is pi by 4. So when this pi by 4s, I will have for 40 times. That is when I can say that, yeah, there are 40 a's because all the a's will be added together. So that is what I have done over here, that I am having 40 pi by 4. That is when this is the area equal to 40a. And then if I simplify this, it comes out to be 10 pi. So from here, we can conclude that k must be equal to 10. And then let me show you that if I had to write this answer in the examination, what would be the steps that I would have followed? I would have written for every pi by 4, area is equal to a. For 40 area, this implies 40 pi by 4. This implies 10 pi. And therefore, a is equals to 10. That is how I would have concluded. But yeah, that's about this question.